All right, we're back. We're on page 6 of notes 10 of Calc C, and we are looking at series. And it looks like what we're going to do here is, I don't know. Oh, find the function the series equals. So we're going to look at each of these and see if we can work out like which function it actually is in disguise. So first thing I do is I always look at the denominator. I look for a factorial. Here, I'm immediately thinking this must be e somehow. So if it's going to be e, then it should be x to the n over n factorial. Anything else is just kind of in the way. So I will rewrite it as x squared times x to the n over n factorial, which is x squared, and then x to the n over n factorial, which is x squared e to the x. And that's what you have to do. So you kind of focus, I always focus on the denominator. Here, 2n plus 1 to me means probably sine. So now I want to get a 2n plus 1 in the numerator. And so to do that, I'm going to rewrite as much as I need to. So negative 1 to the n is part of sine. X to the 2n plus 1 times x squared, because that would give me 2n plus 3 back to the original. 2n plus 1 factorial. So we can take out the x squared, and then we have sine. 1 to the n, x to the 2n plus 1, 2n plus 1 factorial. So it's x squared sine of x. There you go. I mean, like, they're pretty straightforward. They look weird at first. Could I multiply by anything other than x squared? I mean, maybe, potentially, but apparently I never did. So I'm thinking this cosine, and I'm thinking we can rewrite this as this, and that's exactly cosine. So this will be x squared cosine of x. There you go. How about this? Okay, so this is a little bit different, thankfully, because geez. I'm still focused on the factorial, right? So n factorial, I think it's e. So now what I want to do is try to group everything else kind of like in the numerator and make it to the n. So we got x to the n over 3 to the n is x over 3 to the n over n factorial. So like e to the u would be u to the n over n factorial. So this is going to be e to the x over 3. These are great. Like when you doing these, I feel like can help to really like reinforce and help you better understand things. I feel that way. Looks like e again. And it looks like we got a situation here where maybe some extra steps. So x to the n. I always find that like the harder or the more challenging you find a problem, like the more steps you show, the better. But don't show too many. Don't show steps that like you don't need. But if you need to show a step, so like here, I think it's good to do this. Because now that 3 to the negative 2 is definitely coming out. So I don't know, that's 3 to the negative 2, but it's 1 over 3 to the negative 2. So that's actually just 9. And then this, sometimes I don't write the like bounds, or what are they called? I don't know, the indices, maybe. You ever just lose a word? Probably you will lose more words as you age. Not that I'm old, but like I can feel it. I already know, like I'm losing a step, everybody. I'm losing a step. Not really, hopefully. I hope, like, you see those people who are like 100 and they're still just like going strong. It's like, oh my God, like I want to be that person. So what do I need to do? Crossword puzzles, Sudoku, like, what is it? Like, not Brilliant, but there's some app. I don't know, whatever. Is that what I should do? Maybe. All right, what are we doing here? So 2n plus 1. So I need everything that I can to be to the 2n plus 1. Well, how on earth am I going to do that? So I see one thing that I can definitely do. Here on the inside, I'm just going to multiply by x over x, because that'll get me up in the numerator to x to the 2n plus 1, and that's good. This there's too much of, so I'm going to factor a 5 out. So I will take a 5 out, And then I'm also going to take this x out. So this, let's annotate this. This is 2n plus 1 plus 1. So that's where this plus 1 became this 5, right? 5 to the first. And then I'm going to take this x out because I'm using the other one in the numerator. X there. And then we have negative 1 to the n. I have 5 to the 2n plus 1. I have x to the 2n plus 1. So I'm going to make that 5x to the 2n plus 1, 2n plus 1 factorial. So that's going to be 5 over x times sine of x. I think we should stipulate that x can't be 0. You know what? Not really what this is about. X can't be 0, but I'm not worried about domains and things like that on these. How many are there? There's like a million. All right, let's keep going. So again, we focus on our denominator. So now we're looking for things to be to the 2n. There's a couple of things we can quickly do here. So I'm going to make this 1 over 2 squared, right? And then I'll explain that more in a second if you don't see where that came from. Negative 1 to the n, 2 to the 2n, and then that definitely just says nn. Which like you would almost, if you're a small child, you might think nn is 2n. It is not. So that, and then I'm going to make this x squared to the 2n, 22n factorial. So this 4 is from 2 to the negative second, right? So I factored out 2 to the negative second. That's 1 over 2 squared. That's 1/4. That's where that came from. And then I'm going to combine everything at this point and get, this is cosine of 2x squared. All right, looking okay, looking good. This, I don't know, this is just 1 over 1 minus 5x. But this has a restriction, the absolute value of x less than 1/5. That one, what is that even doing here? Maybe it's no, not really. Here, I don't know why, but like, I think it's better to do that. I mean, I guess I always think it's better to do that. So this is going to be 1 over 1 plus, I'm going to go back and look at that last one, make sure I didn't, sometimes I like to mess with the start just to mess it. Nope, it started at 0. So it's that. Awesome. Geometric everywhere. Good deal, good deal. So I'm going to factor this out. 1 over 3 to the negative 4th is 3 to the 4th, which is 81. And then I'll write the sum again. I felt like I was doing really good writing sums for a while there, like the summation sign. Take your wins where you can, you know? So this will be 81. Then we get 1 over 1 minus 2x over 3, which, like, I don't know. You probably want to simplify, but like, is it going to help? Not really. This was the absolute value of x is less than 3. So this is also, right? Not everywhere, just where it converges. And then here, I mean, this is geometric, so we can just do first over 1 minus the ratio, and then the ratio is x minus 3 over 5. So the first term, plug in 0, and you get x minus 3 over 1. So x minus 3 over 1 minus the ratio is x minus 3 over 5. And then that you can simplify, I guess, to something. 5 x minus 3. You get 5 minus x plus 3. 5 plus 3 is 7 minus x. Gross. I'm not even convinced that's right. I think well, 5 minus x plus 3. 5 plus 3 is not exactly 7. That's better. And then we need the absolute value of x minus 3 over 5 to be less than 1. So the absolute value of x minus 3 less than 5. which you can write. You can also think of it as you're at 3, you go 5, 5, so 8, and -2. So I'm going to write -2 to 8 because I think that's better. I don't know that it actually is. Okay, those are fun. I like those. If I went too fast, watch them again. When we hit the geometric ones, I was like, I'm just going for it because we've done those many times. I'm actually not going to do the rest of these in videos because they're not really my problems. And so I don't want to just like, crank out an answer key to somebody else's work. But we'll do them in class. If you're in my class, if you're not in my class, good luck. I think you can probably do it. This is a trick question, so don't fall for it. All right, so I'm going to be back in the next video to actually start the next set of notes. So I will see you there.